Need to expose Python functions as AI-callable tools with just 2 lines of code. We'll create a FastMCP server that registers functions using the @MyServer tool decorator, showing both the basic form and custom naming options. You'll see how to start the server with explicit transport settings, including the default STDIO protocol and HTTP alternatives, using the actual instance name, myServerRun, as shown in the official documentation.
From FastMCP, import FastMCP. MyServer equals FastMCP, custom server. @MyServer tool. Def hello, SDR. Return hello from custom server.
This demonstrates FastMCP's RPC tool registration system, where the @server tool decorator transforms Python functions into callable endpoints within an MCP server instance. The system uses a declarative approach that captures function metadata during import, while keeping transport and execution separate from your business logic. Unlike traditional RPC frameworks, FastMCP provides multiple registration methods including decorators, @MyServer tool or @MyServer tool, custom name, and direct function registration, myServer tool myfunction, all while using type hints to define the interface contract. The pattern operates through distinct registration and runtime phases. When you decorate a function, FastMCP records its signature and type information to build the tool registry, but the tools remain inactive until explicitly started. The server instance, like myServer in the example, manages transport protocols, with STDIO as the default for local integration and HTTP available for network access. You activate the server either programmatically via myServer, run transport equals HTTP, port equals 9000, or through the FastMCP CLI, FastMCP run server, PyMyServer, which gives you control over transport settings while keeping tool definitions clean. This approach eliminates manual route handling and request serialization, making it particularly effective for AI integrations, internal services, or distributed systems, where the server name parameter helps distinguish instances. The separation between tool definition and server execution means your functions stay framework agnostic, while still supporting features like custom tool naming and multiple transport options. The trade-off is that you must explicitly start the server, but this gives you precise control over when and how your tools become available to clients. Let's break it down line by line.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI-callable tool servers that expose Python functions as structured tools. The server name parameter distinguishes instances in distributed systems, and STDIO is the default transport for local testing. Tools are registered via 3 patterns: the @MyServer tool decorator with optional name override, the @MyServer tool, custom name, form or direct registration via myServer tool myfunction. The server remains dormant until explicitly started via myServerRun, with configurable transport options, or through the FastMCP CLI.
MyServer equals FastMCP, custom server.
Initializes the FastMCP server instance named custom server, establishing a registry for AI-callable tools. The name parameter distinguishes this instance in distributed systems, while STDIO serves as the default transport for local testing. This instance supports tool registration via 3 patterns: the @MyServer tool decorator with optional name override, the @MyServer tool, custom name, form or direct registration via myServer tool, myfunction. Tools remain inactive until explicit activation through myServerRun or the FastMCP CLI, with transport options configurable via parameters like transport equals HTTP.
@MyServer tool. Def hello, SDR.
The @MyServer tool decorator exposes this function as an AI-callable tool, using the server instance name custom server to distinguish it in distributed systems. Tools can be registered via decorator, at my server tool, or at my server tool, name, or direct call my server tool my function, with type hints defining the schema. The server starts via my server run, defaulting to STDIO transport but configurable with parameters like transport equals HTTP, host, and port. For production, use my server, run transport equals HTTP, or the FastMCP CLI as documented.
Return hello from custom server.
This return statement defines the exact response payload when the AI calls this tool. The string value gets automatically serialized into the MCP protocol response, with transport handling managed by the server's configured protocol, STDIO, by default for local testing, or HTTP when explicitly specified. To activate this tool, you must start the server instance with my server run, typically wrapped in the standard if name equals main guard. The run method accepts transport configuration like transport equals HTTP, host equals 127.0.0.1, and port equals 9000 for networked operation. FastMCP tool registration. The @MyServer tool decorator transforms Python functions into MCP-callable tools while preserving type signatures for automatic schema generation, supporting both @MyServer tool and @MyServer tool custom name, syntax as shown in the official documentation. Tools remain inactive until explicitly started via my server run, with STDIO as the default transport, or through the FastMCP CLI, which bypasses the main block entirely. Server instances require unique names for distributed system identification, and tools can alternatively be registered via direct method calls like my server tool, my function, name equals custom name. The run method accepts transport-specific parameters including transport equals HTTP, host, and port configurations that determine accessibility scope.
The decorator that names the tool becomes nameless in the protocol, while the unnamed server instance carries all names forward.